Hi, in this video we will sort a list of numbers using insertion sort. The algorithm is based on how you sort a deck of cards in your hand. It goes like this. Take each element from the list and then insert them to their correct location. Sounds easy enough? Let's start typing. First, I make a copy of the input numbers, and then I will go through all the indexes. This is the take all elements part, from the first index to the total number of elements in this list. Please note that this is not the 0th element, so actually we are skipping one, and that is because I will need another variable which will go from I minus 1, so from the 0th element, and we will first check if we can swap the 0th and the first element. And we will do that not in an if statement but in a loop, because for further elements we'll need more comparisons. So first let's check if the 2 index is greater than equal to 0 and if the value is greater than list I. Then we will need to decrement this index, so this is not yet the right position to insert this element. And once this loop exits, the 2 index is going to be the value where we should insert this ith element. And let's do that using the Python insert method. So insert gets the first parameter as the index where to insert, and the second parameter is what to insert. And we will first pop the ith element and then insert it into the 2 plus 1 index. So this is our insertion sort. Let's make this a function. Insertion sort getting a list. There we go. And also let's call this function just to see that it does what we are intending it to do. So sort numbers and then print the results, sorted numbers. And also let's run this code to see if it indeed sorts. Yes, it is nice and sorted already. Now, if you have looked up how things work on the internet, you might notice that this is not the algorithm you find on Wikipedia, and that is because while this is a very intuitive but also a generic way to implement insertion sort, it works well with the linked list type of representation, but Python, for example, does not have a built-in linked list. The problem is, of course, with both the pop and the insert methods, because they will shift all elements after them. First, the entire tail is going to be copied one to the left, and then one more time we will copy the tail starting from a different index, copying one to the right. So this is moving almost all elements at the beginning, one back and forth. To improve the Python performance, we could do the copy ourselves at the same time when we search for the 2 index. So let's try to optimize this. First, copy the entire function and give it a different name, insertion sort array, and let's start to optimize. So we would like to do our copy while we are searching. So we overwrite the 2 plus 1 index element with the 2 index element. Now if we do that, unfortunately we first overwrite the ith element. So in order not to lose that value, we need to make a copy of it. List I into a 2 insert variable, and for the exact same reason we need to replace this list I reference also the 2 insert element. And this way we can eliminate the list insert and list pop calls by just moving the 2 insert element to the I plus 1 index. And this in theory should do the exact same thing but with way less copies. Let's call it and see if indeed it does the same exact thing. Yes, it is the same output as for the more intuitive version. So this is it. Thank you very much for watching, and see you in the next one.